Chapter 26. Making Sense of Everything. Data is raw. Timestamps, clicks, events, numbers. Information is what you get when data is organized, processed, and given context. The gap between the two is where this chapter lives. And in growing systems, that gap gets expensive fast. Nimbus was generating enormous amounts of data. Every order recorded, every menu view logged, every restaurant update captured, every customer interaction tracked. Tom had a question. What's our busiest order time on Fridays? Leo looked at him. That's not in our dashboard. Can we add it? The data is in DynamoDB, and in CloudWatch logs, and in S3 from the analytics export job. Leo paused. In 3 different places, in 3 different formats. Maya added, and the analytics export only runs once a night. If you want Friday data, you'd have to wait until Saturday morning. Tom looked at the screen. So we have the data, we just can't use it. That sentence describes half of modern analytics. This is the data engineering problem. You have data, but it's not in a form you can analyze when you need it. 3 different problems. Nimbus's data problem had 3 dimensions. Real-time streaming. Orders are being placed right now. You want to see a live dashboard of order velocity. How many per minute, by region, by restaurant. The data needs to be processed as it arrives. Data transformation. The data is in S3 from various systems, in different formats. JSON, CSV, Parquet. Before you can analyze it, you need to normalize it. Same schema, same format, cleaned up, joined with reference data. Ad hoc analysis. Once the data is organized, you want to run SQL queries against it without having to load it into a database first. Give me the top 10 restaurants by revenue in the last 30 days, without loading the data into a database. Each of these is a distinct problem. AWS has a dedicated service for each. Amazon Kinesis, real-time streaming data. AWS Glue, data transformation and cataloging. Amazon Athena, serverless SQL queries on S3. Amazon Kinesis, the real-time ticker tape. Amazon Kinesis Data Streams is a real-time data streaming service. Producers send data records to the stream. Multiple consumers can read from the stream simultaneously, each at their own pace. Think of a ticker tape machine. Prices are printed continuously. Everyone can read the tape, and the tape doesn't slow down for any individual reader. For Nimbus, when an order is placed, the application publishes an event to a Kinesis stream. Consumers of this stream, a real-time dashboard, reads events as they arrive, updates metrics. A fraud detection lambda looks for unusual order patterns. A stream to S3 for permanent storage. Kinesis data streams concepts. Shard. The basic unit of capacity. 1 shard handles 1 megabyte second write, 2 megabyte second read. Data stays in the stream for 24 hours, default, to 7 days. Sequence number. Each record has a sequence number. Consumers track their position in the stream. Amazon Data Firehose, formerly Kinesis Data Firehose, the managed delivery service between streaming producers and destinations such as S3, Redshift, and OpenSearch. It buffers, compresses, transforms, and delivers data automatically. For Nimbus, Kinesis data streams, Amazon Data Firehose, S3, Parquet format, compressed, partitioned by date. AWS Glue. Data in S3 is raw. Before you can analyze it efficiently, you need to discover what's there and its schema. What columns, what types. Transform it into a consistent format. Join different datasets together. Handle bad records, schema changes, missing values. AWS Glue is a fully managed ETL, extract, transform, load service. It has 2 main components. Glue Data Catalog, a metadata store that describes your S3 data, what tables exist, what columns they have, where the data files are. It's like a card catalog for your data lake. Glue Crawlers, automated agents that scan S3, infer the schema, and populate the data catalog. Run a crawler on your S3 bucket, and 10 minutes later you have a catalog of all your tables. Glue Jobs, serverless Spark Python jobs that perform the actual transformation. You write the transformation logic or use Glue's visual ETL tool, and Glue runs it on managed infrastructure. For Nimbus, 1. Glue Crawler scans the order's data in S3, creates a table definition in the Glue data catalog. 2. Glue Job transforms the raw JSON order events into a clean, partitioned Parquet format. 3. The transformed data is written back to S3 in a query-optimized layout. Amazon Athena, the librarian. Amazon Athena is a serverless interactive query service that runs SQL queries directly on S3 data. No database to provision, no data to load. You define a table or use the Glue data catalog, write SQL, and Athena executes the query against the S3 files. Code example omitted for narration. Athena pricing is based on how much data a query scans. In many regions, standard SQL queries start at $5 per terabyte scanned. Using Parquet format columnar with partition pruning, where year equals 2024 and month 01 means Athena only scans the files it needs, which dramatically reduces cost. We can run this query for 30 days of data, Leo said, and it may cost surprisingly little if we store it well. For any arbitrary question we can think of, Tom asked. Any question we can express in SQL, against any data we've stored in S3. Tom had the look of someone recalculating the value of all the data they'd been throwing away. The data lake architecture. These three services combine into what's called a data lake architecture, a centralized S3 repository for all your data, with tools for processing and querying it. Code example omitted for narration. The raw data is always preserved in the original S3 bucket. The transformed data is queryable via Athena. New questions can always be answered by running new Glue jobs on the raw data. Amazon Redshift, when Athena isn't enough. For some use cases, Athena is too slow or too expensive. Very complex queries with many joins. Dashboards that run the same query thousands of times per day. Machine learning on structured data. Sub-second response time requirements for BI tools. Amazon Redshift is a fully managed data warehouse, a columnar analytics database designed for large, repeated analytical workloads. Unlike Athena, which queries data where it lives in S3, Redshift loads data into optimized warehouse storage and uses query optimization, sort strategies, and distribution strategies to accelerate complex analytics. Redshift is significantly faster for complex analytics queries at the expense of cost, provisioned capacity, and the requirement to load data before querying. Redshift Serverless removes the capacity planning burden. You query, Redshift scales. Cost is per query. For Nimbus at their current scale, Athena is sufficient. At 5 times the data volume and with BI tools querying the same dashboards hundreds of times per day, Redshift would become cost-effective. Strengths and limitations. Kinesis data streams. Use Kinesis when your data arrives continuously and order matters. Clickstreams, financial transactions, IoT telemetry. Kinesis preserves record order within a shard and allows replay during the configured retention window, which makes it fundamentally different from SQS. The trade-off is operational complexity. In provisioned mode, you manage shard capacity and consumer behavior. For simple task queues where order doesn't matter and replay isn't needed, SQS is the simpler choice. AWS Glue. Glue eliminates the infrastructure of a traditional ETL cluster. You write the transform logic. AWS manages the Spark environment. This is valuable when transforms are complex or data volumes are large. The limitation is cost and cold start. Glue jobs have a startup delay of several minutes, making them unsuitable for near real-time transforms. For simple file format conversions, CSV to Parquet, the overhead of Glue may not be worth it, compared to a Lambda function or a lightweight script. Amazon Athena. Athena lets you query S3 data with standard SQL and no infrastructure to manage. The critical constraint is cost. Athena charges per terabyte of data scanned. A query against a 10 TB table that scans the whole thing costs significantly more than the same query against a Parquet-formatted partition table that scans 200 gigabytes. Always use columnar formats, Parquet or ORC, and partition your data before running Athena in production. Without these optimizations, Athena bills can surprise you. Summary. Amazon Kinesis. Real-time data streaming. Producers write records. Consumers read at their own pace. Amazon Data Firehose can then deliver streaming data to S3, Redshift, and other destinations with less operational work. AWS Glue. ETL and data cataloging. Crawlers discover schemas. Jobs transform data. Data catalog makes data discoverable by Athena and other tools. Amazon Athena. Serverless SQL on S3. Query any data in S3 using standard SQL. Priced per TB scanned. Use Parquet and partitioning to minimize cost. Amazon Redshift. Managed data warehouse for high-performance analytics. Load data in, optimize for repeated analytical queries and query fast at warehouse scale. The data lake pattern: raw data to S3, Glue transforms it, Athena queries it, BI tools visualize it. Exam tips: SAA-CO3 domain. Design high-performing architectures. Domain 3, Task 3.5. Kinesis versus SQS. Kinesis equals ordered, real-time streaming, multiple consumers. Replay within retention window. SQS equals task queue, each message processed once. Multiple consumers reading the same stream simultaneously. Kinesis. One worker per message. SQS. Athena exam signals. Serverless SQL on S3. Analyze S3 data without loading it into a database. Pay per query. Athena. Athena cost optimization. Columnar format Parquet or ORC plus partitioning dramatically reduces data scanned and cost. Exam may ask how to reduce Athena costs. Glue crawler. Discover schema of S3 data automatically. Amazon Data Firehose. Automatically loads streaming data to S3, Redshift, OpenSearch without managing consumers. Amazon Data Firehose. Older materials may still call it Kinesis Data Firehose. Redshift versus Athena. Redshift for high-frequency, complex queries on a fixed dataset. BI dashboards. Athena for ad hoc queries on S3 data that changes frequently. EMR, Elastic MapReduce, AWS Managed Hadoop Spark Clusters. Exam uses this when existing Hadoop Spark workloads or custom data processing frameworks are mentioned. Glue is the managed alternative for most use cases. Exercises. Exercise 1. Recall. Explain the difference between Amazon Kinesis and Amazon SQS. When would you use each? Hint: think about how many consumers can read the same data, whether messages are deleted after reading, and whether order matters. Exercise 2. Exam practice scenario. A ride-sharing company wants to analyze trip data. 1 million trips are completed daily. Trip records are stored in S3 as JSON files, approximately 2 KB each. The analytics team wants to run ad hoc SQL queries like average trip duration by city last week. Queries should complete in under 2 minutes. Storage costs should be minimized. The team will run 20 to 30 queries per week. Which architecture best meets these requirements? A. Load trip data into RDS PostgreSQL daily. Query using standard SQL. B. Use AWS Glue to convert JSON to Parquet format partitioned by date and city. Query with Amazon Athena. C. Use Amazon Data Firehose to deliver trip data to Amazon Redshift. Query with Redshift. D. Load trip data into DynamoDB and use PartyQL for SQL queries. Hint 1. 20 to 30 queries per week is low frequency. Which service is most cost-effective for occasional querying? Hint 2. Parquet format plus partitioning dramatically reduces data scanned by Athena, and therefore cost. Hint 3. 1 million trips times 2 KB equals 0 gigabytes per day. Over a week, 14 gigabytes. At $5 per terabyte for Athena, even without optimization, this is affordable. Answer: B. Explanation: Glue converts JSON to Parquet. Columnar format dramatically reduces data scanned, partitioned by date and city. Partition pruning means last week queries only scan 7 days of partitions. Athena queries S3 directly with standard SQL. For 20 to 30 queries per week, pay-per-query Athena is extremely cost-effective versus always running Redshift. Why not A? Loading 2 gigabytes of data daily into RDS, then querying, requires a database instance running 24/7. For 20 to 30 queries per week, this is vastly over-engineered and expensive. Why not C? Redshift is cost-effective for high-frequency queries, hundreds per day, on the same dataset. For 20 to 30 queries per week, the always-on Redshift cluster costs far more than Athena's per-query pricing. DynamoDB is a key-value document store optimized for key-based access, not ad hoc analytical queries. PartyQL on DynamoDB doesn't support the kind of group-by aggregations described. DynamoDB is a key-value document store optimized for key-based access, not ad hoc analytical queries. Exercise 3, Architecture Challenge. Nimbus wants to build a real-time fraud detection system for orders. The system should detect orders placed by the same account more than 5 times in 60 seconds. Flag orders above $500 from new accounts, except 30 days old. Send flagged orders to a human review queue. Design the architecture. What does Kinesis provide? Where does the fraud logic run? How do you correlate same account, 60-second window? What service receives the flagged orders? There is no single correct answer. The goal is to practice real-time streaming architecture design. Post-credits scene. Tom ran the first Athena query. Top 10 restaurants by revenue last quarter, he said. 12 seconds later, the results appeared. He stared at them. Restaurant 47 was first, he said. It was Maya's family restaurant, the one where Nimbus started. Of course it was, Maya said. Arepa is that good. Tom ran another query, and another. Each answered in seconds, each costing fractions of a cent. After an hour, he had a complete picture of Nimbus's business in a way he'd never had before. Which restaurant categories grew fastest? Which customer cohorts retained the longest? Which menu items drove the most repeat orders? Why didn't we build this sooner? He asked. We had the data, Leo said. We just didn't have the pipeline to use it. The data was always there, Maya said quietly. We just couldn't see it. In the next chapter, now that we can see the business clearly, let's talk about how to pay for the infrastructure that runs it more efficiently.